God bless you, geometry students. Here is the practice geometry test for the upcoming test. For some of you, it will be tomorrow. So I trust you'll be able to look at it sometime before then. And for most of you, it will be on Friday of this week. I'm sorry I couldn't get it up before, but I trust it will benefit you, all right? I want to start with our foundational scripture there. We have here in number 1 to write a scripture which reveals one attribute of God and tells how he feels about right triangles or things that are right. The scripture is from Psalm, and I trust you know it by now. It says, "For the Lord is righteous, he loves righteousness, his countenance beholds the upright." Notice a change in this word beholds instead of what I was saying before, upon. It should beholds the upright. So I'm confident that everything that is right that we study, his eyes are upon those things, because that's very much like what he is. Now, Numbers 2 through 4, the instructions are: find the unknown side length. Write your answer in simplest radical form. So let's go ahead and look at number 2. This is a right triangle, and we're given 2 side lengths. And once we're given 2, we can easily find the missing third one. So we're going to use the Pythagorean theorem: c squared equals a squared plus b squared. And it's very important to clearly identify the c. I trust by now everyone knows that the c is going to be the hypotenuse one right across from the right angle. So it's going to be a 9 squared here equals x squared plus 3 squared. 9 squared is 81. X squared plus 3 squared is 9. Subtract 9 from both sides. That gives us 72. So we have x squared is equal to 72, and to find x from x squared, take the square root of 72, and for simplest radical form, you just think about two numbers when multiplied together to give you 72, one of which is a perfect square. You try to find the highest one. You might think of 9 and 8, but a higher one would be 36. 36 times 2, that would be 72, where 36 is a perfect square. So the square root of 36 would be 6. And 2 is not a perfect square, so you leave it as is. So your answer would be 6 root 2, or 6 radical 2. So that's the way you would do these by the Pythagorean theorem. Okay? I'd like you to practice number 3 and number 4, or the ones I gave you from EP 14. Now let's take a look at some more concepts here. We've got For numbers 5 and 6, complete or answer the following for questions 5 and 6. State the Pythagorean theorem. And I trust you'll be able to do that. And that simply says in a right triangle, I told you, there's nothing wrong with this triangle. In a right triangle, the square of the hypotenuse is equal to the sum of the square of the legs. Hypotenuse is equal to the sum of the square of the legs. Sum of the, I should say, the squares of the legs. Here's another conceptual one. I'm going to leave that one to you. In a 30, 60, 90 triangle, the length of the, and you've got notes on that, so you'll be able to finish that one and study that one well. Now, for numbers 14, 15, and 16, I think I might have skipped a page. Let me go back. Yeah, here's a page I skipped. I think I reviewed this with most of you. Let me just do one of these as a reminder. Classify the triangle by the side lengths as acute, obtuse, or right. Okay, so let's just go ahead and do, we've got quite a few of them here. Let's do number 9. We look at number 9 and we see 8, 16, 8 root 3. So we've got to determine which is the longest as we compare c squared with a squared plus b squared. So 8 times root 3, I have to go to my calculator to find that one out. Square root of 3 times 8, I'm getting 13.86 about that. So for this, it's coming out to be about 13.86, almost 14. So the C here in number 9 would be number 6, that be a side length 16. So I do 16 squared compared to 8 squared plus 8 root 3 squared, and I see I forgot the square on the 8. 16 squared, some of you might know this, it's 256. 8 squared, of course, is 64. And 8 root 3 squared is going to be 8 squared times root 3 squared. So this would be 64 plus 8 squared is 64. And root 3 squared is 3. And 3 times 64 is going to give me 3 times 4 is 12. I'm going to put it up here. 3 times 4 is 12. 3 times 6, 18, and 1, 19. Got 192 plus 64. 4 plus 2 would give me 6. 9 plus 6 is 15. 1 plus 1 is 2. So I got 256. I think I made a mistake here. 4 plus 2 is 6. So that's 256. So for this one, I get 256 for c squared. And I get 256 for a squared plus b squared. So for number 9, the verdict is it's a right triangle. If c squared were greater than a squared plus b squared, then that would be an obtuse triangle. If c squared were less than a squared plus b squared, you'd have an acute triangle. But that's the way you do these. All right. I think we've already done one on the area, so I'm going to leave that one. Let's take a look at special right triangles. It says find the value of each variable in the right triangle shown. Do not use a calculator. So here we've got a 45, 45, 90 triangle. I get the length of one leg, so I easily can find x, because the theorem says the length of the hypotenuse is the square root of 2 times the length of a leg. So x would be 7 times the square root of 2, and y, the other leg, would be, I trust by now you know that would be 7, because this is isosceles. 45, 45, 90. Here's another one. I should have marked this as isosceles, so you know it's 45, 45, 90. This time they give us the hypotenuse is 12 root 2, so we know working backwards now this leg would be 12, and this leg would also be 12. Now we transition over to the 30, 60, 90. You say, how do you know it's 60? Well, once this is 30, this is going to be 60. And the 30, 60, 90, the length of the longer leg, which is what they give us, is the square root of 3, not 2 now. Square root of 3 goes with the one with 30. It's going to be the square root of 3 times the length of the shorter leg. So the shorter leg n must have been what? 7. And the hypotenuse, as the theorem says, is going to be twice the length of the shorter leg. That'll be twice 7, which is 14. All right. Progressing now to our trigonometric considerations. It says for the righteous triangle shown, write the specified trigonometric ratio as a fraction and also as a decimal. Where possible, round your answer to 4 places. So tan of angle B, here's angle B, and tan, that would be the TOA, is opposite over adjacent. So that would be 12 over 5. And it will be just a matter of going to your calculator and putting 12 over 5. If you do that carefully, you would get, I'm just going to do it right now, 12 over 5, that's 12 divided by 5, and that gives me 2.4. Okay, sine, that's so. So, the sine ratio is opposite over hypotenuse, so sine of angle A, the spotlight is on angle A, and the opposite to angle A is 5, and the hypotenuse is 13, so that would be 5 over 13, 5 divided by 13. When I go to my calculator on that one, I get 5 divided by 13, and that gives me 0.3846. Okay, so that would be, and if you want to find the cosine, which I don't have here, but the cosine of, let's say, angle A would be adjacent over hypotenuse, and that would be 12 over 13. You could work that out using your calculator also. Finally, use one of the trig ratios to find the value of x. And in this one, we want to find x, so we have this angle here, 35. So since x is adjacent to it, this is the hypotenuse, we would say ka for adjacent. So cosine of 35 would be equal to adjacent, which is x, over what? Hypotenuse, which is 16. So we cross multiply and we get x times 1 is x, and our answer is going to be 16 times the cosine of 35. I can easily work